Okay, so this is our outcome after estimating our model, and you can see these are the independent variables: x1, x2, x3, x4, x5, x6, x7, and y is the dependent variable. And here we have used entire method to estimate this model, and that is the outcome, right? Okay. Then our second outcome that we have, I go down. So it is our model summary. You can see from here, right? Model summary. And here you can see, our model summary is this one. So here the R squared value is how much? R squared value is actually this one, 72.5%, right? So this value is quite high. So normally I say if the R squared is more than 70%, meaning that the model is nicely fitted. Model is nicely fitted if the R squared is more than 70%. Normally I say, so meaning that if the R square is high, more the R square, more the fitted. Higher the R square, higher the fitted of this model. And here R square is quite big, almost 72.5%. So nicely fitted. And we check how many independent variables are significant. We can check from the below. We come here. So from here we can check how many independent variables are significant. You see from here. So you see from here that is these are the independent variables, right? x1, x2, x3 until x7, and this is the significance level, and we can also call it p-value. We can also call it p-value. Just 1 minute. Okay, we can also call it p-value. P-value, or we can call it sig value, right? P-value or sig value is the same meaning, no difference. So normally we say if the p-value is less than 5%, then that particular variable becomes significant. But here the p-value or sig value is all more than 5%. Suppose I talk about this one, this value 55.8%, right? So it is more than 5%. As a result, the x6 is not significant. Okay, then I talk about this one, the sig value or p value, how much? 28.9%, and that is more than 5%. So x1 is not significant. So in this way, here you can see none of the variables are significant because p-value or sig value is more than 5%. Okay, so the question is that when a model is suffering from multicollinearity, what are the symptoms? Symptom of multicollinearity, that we can check now. What are the symptoms are there? Okay, symptom of multicollinearity. So I write the symptom symptom of multicollinearity. So the symptom is when the R square value is high, R squared is high, but none of the independent variables are significant, or only very few independent variables are significant, we can suspect that particular model is suffering from multicollinearity. So okay, the thing I am telling again, what is the symptom of multicollinearity? The symptom is when R square value is very high, but none of the independent variables are significant, or very few independent variables are significant, then we can say that probably that estimated model is suffering from multicollinearity. Okay, so what about our model? Our model, we can see our R squared is very high, almost 72.5%, and none of the independent variables are significant. So we can say that probably our model is suffering from multicollinearity problem. Okay, but we can double check whether our model is suffering from multicollinearity. There are some guidelines. Okay, what is the guideline? Number one guideline, that is the value of VIF should be more than 10, or tolerance should be less than 0.2. Then we can say that a particular model is suffering from multicollinearity. Okay, we check it. You can see here VIF, right? You can see the VIF. The value of VIF, suppose this one is 26.03, this one is 30.86, this one is 20.3, which is more than 10, meaning that this model is suffering from multicollinearity. Okay, again, the tolerance, you can see the tolerance. These tolerance, suppose here, all these three, right? All these three are less than 0.2, right? So as a result, this model is suffering from problem of multicollinearity, because VIF is greater than 10 and tolerance is less than 0.2. Okay, so now we are sure that this model has become multicollinearity problem. As a result, none of the variable has become significant. And here what is called tolerance level. Actually, how to estimate tolerance? The formula is 1 by VIF. That is the formula. Suppose this one means, how to get it? 1 divided by 3. You can get it. How to get this one? 0.49. 1 divided by 20.3, you can get it. So that is the tolerance all the time. This is the way you can get the tolerance, 1 by VIF. Okay. So now we are sure that this model is suffering from multicollinearity. Okay, the question is that when there is a multicollinearity, what it happens? Okay, okay, that I shall be talking now. Okay, when there is a problem of multicollinearity, what happens? Okay, normally, what is T statistics? T statistics means actually it means equal to coefficient co, co coefficient estimated coefficient divided by standard error. That is the formula to estimate T statistics all the time. Okay, and here what is happening? You can see from here, and here you can see. So meaning that what is this T statistics? Meaning that this one, right? T statistics, this one, right? Sorry, this is the T statistics, right? You can see from here, T statistics. Okay, meaning that suppose I talk about this one, 1.431. This is the T statistics, and what is it? Coefficient. You can see the coefficient, that is unstandardized coefficient. You can see from here, right? So meaning that 1.291 divided by standard error 0.902, you can get the T value, that is 1.431. That is T statistics formula, right? This one. Oh, sorry, why it coming down? Okay, this one, right? This one, T statistics coefficient divided by standard error. Okay. Then what about, suppose I talk about this one, 0.859. How to get it? The same thing. The coefficient is how much? 0.116 divided by standard error, that is 0.135. As a result, I can get this value, meaning that 0.859. Okay, so this is the way to calculate T statistics. And this is sig value, meaning that P value. Sig value and P value is the same, that I said last time, right? And what is the association shape between T and P? This is P value, right? Or sig value, same meaning. So normally what happens when the absolute T value, what does mean by absolute T value? Meaning that there is no negative sign, no negative sign or positive sign. That is called absolute T value. So what happens when the T value goes down, then P value goes up, or when the T value goes up, P value goes down. That always happen. Suppose here I am giving example. Suppose here the T is big, as a result the P value is small, right? Okay, that is one example. Another one, suppose here that the T value is small, absolute T value is small, as a result P value has become big, and that is always happen. And the problem is that, and so meaning that when absolute t goes down, p goes up, or absolute t goes up, p goes down. Okay, that means, and this p is becomes significant when the p value is less than 5%. So that is the guideline all the time. Okay, that I mentioned the guideline here, that I said here, that is I said last time that I'm here, okay, that I said last time, when the p value or sig value less than 5%, then a particular variable becomes significant, right? That is always happening. Okay, now the thing is that this model is suffering from multicollinearity, and when a model suffer from multicollinearity, then it makes the standard error high, right? I am saying again, when a model has multicollinearity, it makes the standard error high, meaning that it makes this one standard error high. Standard error goes up when there is a problem of multicollinearity. So when the standard error goes up, then t statistics goes down. This one goes down because this one remained fixed, right? This one remained fixed. It goes up artificially. It goes up artificially. As a result, t statistics goes down. And when the t statistics goes down, then p value goes up, right? Because t and p has a opposite associationship all the time. So when t goes down, p goes up. And when the p value goes up, that particular variable cannot become significant, because a variable can become significant when the p value is less than 5%. But here all the p value are more than 5%. Why? Because the t value has become very small due to the problem of multicollinearity, right? Normally, if the t value is more than 2, then a particular variable becomes significant normally. But here all the t value are less than 2. All the absolute t value are less than 2. As a result, all the p value are very high. As a result, none of the independent variables are significant. Okay, so our task, our job today is to remove the multicollinearity from this model. As a result, some of the independent variables can become significant after removing the problem of multicollinearity from this regression model. and that I shall be doing now.